Welcome to this third video on web service composition. The topic of this video is choreography. So, as before, why choreography? Again, the name comes from an analogy, and you can think of a ballet, dancers, or for example a theater where you have actors and they simply know what to do on stage. So there's no director who tells each individual dancer where to move, how fast, and so on. It would be too complex for the director, and it would be also impossible for the dancers to follow the director. So the only way to manage this kind of collaboration on the stage is by having dancers simply learn their part and then agree with all the other dancers and jointly perform the performance, essentially. If we go to web services, where's the analogy? So let's take again the four web services we had also in the case of the orchestration video. And in this case, we have web services that not only know how to execute their own internal business logic, but they also know how to interact with the other web services. So first of all, this means they know which are the other web services and they know how to talk to them. So in this case, for example, we have one web service who starts the whole process, the whole composition, and invokes a second web service who, I don't know, does something internally with the input gotten from the first web service, forwards it to a third web service, who then interacts with another web service, gets feedback back, and this closes essentially the process, meaning the choreography. So how do they know how to interact with each other? As I said, when they just know it. Not really. In a sense, there is a collaboration protocol or a contract they all comply with. Where does this contract come from? Very likely they just sit together at some point in time and agree on how to collaborate. You need to imagine that the web services are not just the technical pieces of software, but behind the web services there are developers, there are companies, there are institutions that can talk to each other and that can agree on how to work together. So this is called a choreography. So more precisely, a choreography, the definition is very similar to the one of orchestration, but here in red I highlight the key different word. So choreography is a distributed integration logic that describes how web services must interact with each other with each other at the message level so as to achieve a given goal. And we can say it's an interaction agreement or even a contract among partners. As said, the key difference with the orchestration is that we don't have an orchestrator in this case. So why don't we have it? Because the service providers or the services already know how to work together when they don't need to have somebody else telling them what to do. They just know how to do it. And there's also another reason, which is simply this, that perhaps we are talking about a composition or a process where nobody wants or nobody needs to take the responsibility of executing the whole process. What does this mean in practice? Imagine you have a composition that involves several services in the financial domain and you want to move, I don't know, 10 million euros from one service to another service. If you make an orchestration to orchestrate the process of moving the money from one service to the other, there will be an orchestrator. That orchestrator might be you. So if something fails in your orchestration engine, whatever, just a power outage in your company or whatever, you are liable. So you are responsible of the money lost somewhere. So I guess you wouldn't be happy about this. So that's why there is a need in some business transactions, in some collaborations between services, there is a need for a paradigm where there is nobody who takes the responsibility. Everybody is somehow responsible for their own part of the process, but not for the whole process. And this is simply a business need that is there. And yeah, it's more a business need than a technical need. And in order to achieve this kind of integration, it is important that the participating services really know what's going on. So they are fully aware of the collaboration, and internally they implement all the necessary business logic that allows them to collaborate, that allows them to work with the other web services. So from a technical point of view, this is actually a bit less intriguing, and it involves definitely less IT than an orchestration, where we have an orchestration language, a composition schema, and we have an orchestration engine. Let's see an example of a choreography, how this could look like in practice. We take the pen. We have again a very simple orchestration. In this case, we just have 3 partners collaborating. We have a customer web service, we have a supplier web service, and then we have a warehouse web service. What we want to do, we want to order some goods. So it is the customer who initiates the collaboration with the supplier web service. He sends a request quote message to the supplier, gets a feedback from the supplier. Then it assesses how interested he or she is in the offer and places an order for the goods. Then in response to this, the supplier web service interacts with the warehouse web service and checks the availability of the goods. Let's say the goods are available and the supplier sends back a confirmation of the order to the customer. In response to this confirmation, the customer sends a payment to the supplier web service, which then sends an order shipment message to the warehouse web service. The warehouse web service, before going on with its internal work, gets in touch with the customer web service and asks for the shipment details. After getting the shipment details, or let's say that it is then the customer web service who sends back the shipment details together with the confirmation of the shipment. Then, in response to this confirmation, the warehouse can ship the ordered goods and confirm the shipment with the supplier web service. Let's see a concrete example of a language that allows us to specify a choreography. Specifically, let's have a look at the Web Service Choreography Interface, WSCI. WSCI is an XML-based interface description language describing the flow of message exchanges between a service and its client. WSCI allows you to specify temporal and logical dependencies among message exchanges and to specify, let's say, correlation conditions for messages. The important aspects of WSCI is, as highlighted in the slide, that it is a client-server model. So WSCI only tells you how to interact, or let's say how the interaction between one web service with its client is to be performed. It does not take a global point of view and does not allow you to explain how 3 web services, for example, have to interact, like the 3 web services we saw in the example before. In order to do that, we would have to integrate the 3 WSCI specifications of the 3 individual web services. WSCI works in conjunction with the web service description language WSDL, and in fact it can be embedded into a WSDL file. We will see an example next. The official reference of the WSCI specification is a W3C node that you can find on this web address. Let's see a simple example of a choreography. We have again 2 web services interacting. We have a traveler and we have a travel agent. The travel agent essentially just booking a flight for the traveler. We have 3 operations exposed by the travel agent's web service through the WSCI interface. We have a receive trip order operation, we have a receive confirmation, and a send statement back to the traveler. So let's see the XML version of this WSCI specification now. We start from the WSDL file of the web service of the travel agency. Here we have on top the common definitions and namespace definitions of the WSDL file, and then next we have the WSDL specific complex type definitions, message definitions, operations, port times, and so on. The WSCI specification, we can just embed inside the definitions tag of the WSCDL file. Specifically in this case now, we define here a correlation set that tells us how to correlate the message between the customer or the traveler and our travel agency. Why do we need this? Because we need to get a confirmation back from the traveler, and if we have multiple travelers sending confirmations, we need to be able to understand which confirmation refers to which running process on our own web server. We will see how we use this correlation set in the next page, which is here. And this is the interface that is the most interesting one, where we describe the interaction between the travel agency and the traveler. So this is an interface called Travel Agent, and it implements a so-called process. The name of the process is Plan and Book Trip, and a message incoming to this instantiates this process. So internally we have again a very simple set of actions. We have a sequence of 3 different types of actions. We have a receive trip order from the traveler to the travel agency. Then we have a receive confirmation message from the traveler again to the travel agency. Internally here we invoke another process, which is the booking process that we implement internally, we being the travel agency. And then in the end we send the message back, the statement of the booking back to the traveler. So we have here an interface definition that tells our client, meaning the traveler, that the correct interaction with our web service is a sequence where we first receive the trip order, then we receive the confirmation, and then after booking the services, the flight or the whatever travel, if we book that successfully, then we send a statement back to the traveler. Next, there is another small process definition, which is our invocation of the actual airline here, where we book the seats, but this is not so important. What I want to summarize here is simply that this WSCI specification essentially describes a state machine, and the state machine tells the client of our service how to interact with us. In this case, we are in the very first step, or in the first state, we are just waiting for trip orders. Then once we get the received trip order, we go into another state, which is the waiting for confirmation state. And as long as we are waiting for the confirmation state, nothing happens until we get the receive confirmation, invoke the receive confirmation operation by the traveler. If we receive the confirmation, we go into the processing order state, where we start interacting with the airline and where we start booking the actual trip. After booking the trip, we send the statement back to the traveler, and this closes the whole process. This sounds now very trivial, but the important thing, or the lesson that we learn from this state machine, is that if we are in the waiting for trip order state, the only message, the only operation invocation that makes us move forward is a receive trip order. If in this state we get a receive confirmation, nothing will happen, because this is simply not allowed in this waiting for trip order state. Similarly, if we are in the waiting for confirmation state, we need a receive confirmation message in order to progress. Other messages, for example the receive trip order message, are simply not allowed, or they would just be discarded. Let's now have a look at the more complex specification, the Web Service Choreography Description Language, WS-CDL. So WS-CDL is also an XML-based language, but in this case to describe peer-to-peer collaborations among multiple participants. So just to clarify, WSCI was a language, or is a language, to specify the conversation between one web service with its client. In WS-CDL, we can take a global viewpoint and we can, in one specification, we can express the collaboration of multiple partners interacting in a peer-to-peer collaboration. Then, similarly to WSCI, also WS-CDL is independent of the supporting platforms or the programming models used by the implementation of the individual services. It is not meant to be embedded into a WSDL document, and it is meant to be a known document with a known lifetime. This because it is not bound to any specific service in the conversation. Finally, the official reference of WS-CDL is again a W3C candidate recommendation that you can find on the website of the W3C. In this introductory class here, or video, it doesn't make sense to go into all the details of WS-CDL. I'm already happy if you know the name and you understand the difference between a client-server choreography language and a peer-to-peer choreography language with a global viewpoint. Before closing, let me just clarify 2 or 3 aspects of orchestration and choreography. Oftentimes you will hear the terms or the adjectives private versus public when speaking about orchestrations and choreographies. Typically the orchestration is associated with the so-called private perspective on web service compositions. Private because the orchestrator is typically executed inside one reality and, let's say, one company or one institution, and nobody from the outside needs actually to know how the process is executed internally. And public is associated with the choreography because it refers to the publicly exchanged messages that flow through the network, through the internet, for example. So, from my point of view, this is not a very characterizing property in service composition. Also, an orchestration generates messages that are exchanged over the web and over the network. So I don't like very much talking about private versus public. To me, the key distinguishing feature between an orchestration and the choreography is that an orchestration has a central controller, while the choreography does not. Then, in the first video of this lecture, I put the 2 terms orchestration versus choreography, saying that there are 2 different approaches, 2 different philosophies to approach service composition. Of course, they are very different. And it's not that you can freely choose which one you want to use. It very much depends on the problem at hand. As I explained before with the example of transferring 10 million euros from one service to another, it's relatively easy to understand that you would prefer to use a choreography. While if it's just about invoking a simple travel booking service, maybe an orchestration is fine as well. And it is the problem that leads you to the type of approach to choose. So rather than saying orchestration versus choreography, it should be orchestration and choreography, meaning that they are complementary. Depending on the problem, you use either one or the other, or in a bigger context, you will very likely use both. You might have an orchestration inside one company, an orchestration inside another company, and then the collaboration among the 2 companies that may be, for example, ruled by means of a choreography. Okay, thanks for watching. That's it for this video.